two great wars that defined a century. Two iconic shelters born from necessity. Their simple, curved shapes are etched into the landscape of history, from the fields of France to the islands of the Pacific. The first was a British invention of World War I, the Nissen Hut, a marvel of speed and simplicity. The second, an American evolution for World War II, the Quonset Hut, a complete, engineered building system designed to be shipped across the world. The Quonset was newer, stronger, and more livable. It was a product of 25 years of technological progress, which lead to a simple but perplexing question. Why was the American Quonset Hut, by most accounts, a slower and more complex structure to build than its British predecessor? The answer reveals a fascinating story about engineering, priorities, and how to build for two very different kinds of war. Our story begins in 1916, in the mud and stalemate of the Western Front. The armies were dug in, but the war was not entirely static. Men and material were constantly on the move behind the lines, requiring shelter that was cheap, plentiful, and above all, portable. The problem caught the attention of a Canadian-American mining engineer serving with the British Royal Engineers, Major Peter Norman Nissen. He had experience with prefabricated structures, and he saw the desperate need for a better solution than the tents and huts then in use. In April of 1916, Nissen began to sketch out his ideas. His design was guided by three core principles. First, it had to be economical with materials, especially steel. Second, it had to be portable. The entire structure needed to be packable into a standard British Army wagon. And third, it had to be simple to erect on site, using minimal manpower and no special equipment. After a few prototypes, he perfected the design. The Nissen Hut was born. Its genius was its structural simplicity. A series of preformed steel ribs were set into ground or on a foundation. These ribs were connected by wooden purlins, creating a sturdy semicircular frame. Over this frame, sheets of corrugated iron were laid, forming the roof and walls in a single step. The result was a structure that could be put up with incredible speed. It is reported that a standard hut could be erected by 6 men in just 4 hours. This speed was its greatest asset. It meant shelter for troops, supplies, or medical facilities could appear almost overnight, exactly where it was needed most. Inside, they were basic. The standard models had no insulation, and the curved walls made placing furniture awkward. But they were dry, they were sturdy, and they were a vast improvement over a tent or a hole in ground. The British government was so impressed that production began on a massive scale. It's estimated that at least 100,000 Nissen huts were produced during the First World War. They became a ubiquitous sight, serving not just as barracks, but as churches, hospitals, and storehouses. The simple hut designed by Major Nissen had become an essential tool of the war effort, a testament to brilliant, practical design. For his invention, Nissen received an award and royalties, but he waived most of the money during wartime. His focus had been on solving a problem, not on profit. The Nissen Hut was a perfect solution for the specific challenges of World War I. But a new and very different global conflict was on the horizon, and it would demand a new kind of shelter. When the United States entered the Second World War in 1941, it faced a logistical challenge of unprecedented scale. This wouldn't be a static war fought from trenches. It would be a global war, fought across oceans, on remote islands, and in extreme climates from the tropics to the Arctic. The U.S. Navy, in particular, needed to build bases fast. They needed airfields, barracks, hospitals, and workshops on islands that were, just weeks before, dots on a map. They needed a building in a box that could be mass-produced in America and shipped to the front. The British Nissen Hut was a known quantity. The design was even used in some capacity by the Allies in World War II. But the American military wanted something more. They needed a structure that was not just a temporary shelter, but more durable, insulated, and complete building. The task fell to the U.S. Navy's Bureau of Yards and Docks. In 1941, at their newly built base at Quonset Point, Rhode Island, they commissioned the George A. Fuller Construction Company to design and manufacture a new prefabricated hut. They started with the proven design of the Nissen Hut as their inspiration. But the American team would make a series of critical changes that would create a superior building, but one that sacrificed the raw speed of the original. They would call it the Quonset Hut, named for its birthplace. And it would go on to become one of the most recognizable symbols of America's industrial might and global reach in the Second World War. To understand why the Quonset Hut was slower to build, we have to look at its most fundamental design difference from the Nissen. The Nissen Hut was a framed structure. It had an internal skeleton of steel ribs that held up the outer skin of corrugated iron. The American designers at the George A. Fuller Company created a frameless or self-supporting structure. The corrugated steel sheets themselves were bent into a tighter curve and bolted together to form both the structural arch and the exterior skin simultaneously. This was an ingenious solution for mass production. But on the ground, it meant assembly was a process of bolting together dozens of individual panels and hundreds of bolts just to create the main arches. And that was only the beginning. The Quonset was designed as a complete building system, far more complex than the basic Nissen. The standard kit came with everything needed for a finished, all-weather building. Between the outer steel shell and the interior, there was a layer of insulation. The interior itself was lined with pressed wood, known as masonite, which provided a smooth, paintable surface. The hut was designed to sit on a raised wooden floor, which was also part of the kit. This kept soldiers and equipment off the damp or frozen ground, a major improvement in comfort and livability. The kit included doors, windows, and a chimney flue for a stove. It was, in essence, a complete house in a crate, designed for assembly by semi-skilled sailors, the famous Seabees, with a set of instructions and basic hand tools. The most common model, the T-rib, came in various sizes, but the standard was 20 feet by 48 feet, providing nearly 1,000 square feet of usable space. The entire package, weighing several tons, could be shipped in crates taking up about 350 cubic feet, and the scale of production was staggering. While the exact number is debated, it is widely reported that between 150,000 and 170,000 Quonset huts were manufactured during World War II. They were deployed to every corner of the globe, providing the backbone of American military infrastructure. They proved their worth as barracks, command centers, hospitals, and chapels, adaptable to nearly any purpose and any climate. The Quonset Hut was a triumph of American logistics and manufacturing. It was a more robust, more comfortable, and more complete solution than its World War I predecessor. But all of this came at a cost, not in money but in time. So let's put them head to head. Why, step by step, was the Quonset slower to erect? The answer lies in the philosophy behind each design. The Nissen Hut was designed for one primary goal: rapid erection of a basic shell. A small crew could plant the lightweight ribs, quickly attach the wooden connectors, and then simply lay the corrugated iron sheets over the top, securing them to the frame. The famous 4-hour construction time by a crew of 6 produced a functional, if Spartan, shelter. Finishing work, like adding a floor or insulation, was a separate, secondary task, often done later or not at all. The Quonset Hut, by contrast, was designed to be a complete building from the start. The process began with constructing the wooden floor and foundation, a significant step not required for a basic Nissen. Then came the most time-consuming part, assembling the arches. Instead of a few lightweight ribs, a crew had to bolt together many individual, heavy steel panels on the ground to form each arch. Once assembled, these heavy arches had to be lifted into place on the foundation. After the main shell was bolted together, the work moved inside. Crews had to install the insulation blankets and then painstakingly fit and attach the masonite interior panels to cover the entire curved surface. This multi-layer process was integral to the design, not an afterthought. So the comparison of speed is misleading. The 4 hours to build a Nissen Hut created a basic, uninsulated shell. The time to build a Quonset Hut, which would take a crew of 10 a full day or more, created a fully insulated, floored, and lined building. One was a tent made of steel, the other was a prefabricated house. The Quonset was slower because it was accomplishing much more from the very beginning. It was a system, not just a shelter. This difference in philosophy is also why the Quonset Hut had such a successful post-war life. Its robust, insulated design made it easily adaptable for use as homes, businesses, and community buildings, a legacy that continues to this day. While Nissen huts also saw post-war use, their simpler, uninsulated construction often relegated them to agricultural or storage purposes. They were a product of wartime expediency. Ultimately, the question of speed isn't about which hut was better. It's about which hut was better suited for its specific mission. For the static, high-density warfare of World War I, the Nissan's rapid deployment was paramount. For the global island-hopping campaigns of World War II, the Quonset's durability, comfort, and completeness as a system were far more critical for establishing long-term, functional bases thousands of miles from home. The story of the Quonset Hut is inseparable from the story of American industrial might in World War II. The ability to design, produce, and ship over 150,000 of these complex building kits around the world was a logistical feat as impressive as any battle won. By 1945, these steel arches formed the backbone of the American presence abroad. They stood on the captured airfields of the Pacific, served as headquarters in liberated Europe, and housed personnel from the desert of Africa to the frozen tundra of the Aleutian Islands. When the war ended, hundreds of thousands of prefabricated huts, both Nissen and Quonset, were left scattered across the globe. Their military service was over, but a new chapter in their lives was just beginning. The U.S. military sold many of its surplus Quonset huts to the public. Their strength and easy assembly made them attractive for a variety of uses. Universities bought them to use as student housing to accommodate the influx of veterans on the GI Bill. Many were turned into affordable homes, quirky roadside businesses, workshops, and community halls. The same durability and insulated design that made them effective military bases made them practical, long-lasting civilian buildings. The Nissen Hut also found a long post-war life, particularly in Britain and the Commonwealth. Their simpler, cheaper construction made them ideal for agricultural use as barns and storage sheds, a role many continue to fill to this day. Today, the arch-style steel building remains a popular choice, a direct descendant of these wartime innovations. The legacy of both the Nissen and the Quonset is written in corrugated steel, still providing shelter around the world, more than a century after the first design was sketched in the trenches. So, why was the World War II shelter slower to build than its World War I predecessor? The answer, we've seen, is a matter of definition. The premise itself is flawed. One cannot compare the speed of building a basic shell with the speed of assembling a complete, insulated, and floored building system. The Nissen Hut was faster because its task was simpler. Major Nissen designed a perfect solution for a static European war, a lightweight, portable shelter that prioritized speed and economy above all else. It was a brilliant piece of battlefield engineering. 25 years later, the U.S. Navy and the George A. Fuller Company designed the perfect solution for a global expeditionary war, a robust, comfortable, and complete base that prioritized durability and livability for long-term deployments. The story of the Nissen and the Quonset is not a story of one being slower or faster, better or worse. It is a story of evolution, a story of two clever solutions born from necessity, each one the right hut for the right war.